Okay, so tonight we're going to be talking about lime mortars, pretty much everything and anything to do with lime, the background, how, and particularly how we use it, how we're supposed to use it in building conservation. There is a lot of terminology which often gets misunderstood. Hydrated, non-hydrated, hydraulic, non-hydraulic, a hydrated, non-hydraulic lime, and every other variation on the theme. And in a lot of ways, there's a lot of mistakes made in the construction industry by surveyors and architects as much as by contractors, and about the misuse of these products. So this presentation tonight is going to be talking about really the background to it and where it's all going from. So let's go back to square one. What did the Romans do for us? It was quite a famous sketch in Monty Python, but one of the things that's relevant to us particularly is I think they are quite instrumental in being acknowledged as having invented what we would now consider to be a lime mortar. Although, of course, they wouldn't have interpreted it or called it a lime mortar, and in those days they wouldn't necessarily have used the words hydraulic or non-hydraulic. To them, it was just a material which they got out of the ground, worked out how they could use it, worked out how it went hard or less hard, depending on what they wanted to use. So buildings such as the Colosseum here and this amazing arch, I've forgotten the name of it, but these are not just mathematically amazing pieces of physics, which are now sort of 2,000 years old, but what they really are really great examples of how even without the knowledge that we now have, they were able to effectively create a mortar. Now, Vitruvius, who wrote this book, not this actual book clearly, because this is a paper copy, Vitruvius, so this is now over 2,000 years old. In this book, Vitruvius' 10 books of architecture, he explained about what we now would interpret as being a lime mortar. And it's astonishing that they had this understanding of the science and the chemistry of what makes a lime go hard, how you can make it harder or softer by varying the proportions of the mix. And I think if any Roman was to look at how we make lime mortars today, they would still have a clear understanding of what's going on. So this image we're seeing here, this is bringing it a bit further up to date. This is 12th century, and this is from a wall in Rye. Now, this has never been repointed, so what you're looking at here is genuine 12th century lime mortars, and you can see there's a bit of shell in there, some aggregate, some stone. These white unburnt bits of lime we'll get onto in a little while, but essentially you would recognise this now as being a lime mortar, despite the fact that this is sort of 800 odd years old. And moving forward a bit, we've got this chimney stack picture here, and this has never been repointed either. This is 16th century lime mortar, but despite the fact that this is best part of 500 years old, we would still recognise it as having been what we would recognise today as being a lime mortar. So the knowledge and the science has been there for quite a while. Right. So in this country, the limes and the limestones, chalks, this sort of thing, primarily are down the eastern parts of the country. When you go towards the central and northern, and certainly towards the west, geology gives us much harder stones, and they're not suitable for creating mortars and limes out of. So the areas that we're focusing on about being able to get the limestone and chalks out are primarily down the eastern side and the central parts. And these chemically are all what we now would call non-hydraulic lime. We don't have any sources of hydraulic limes in this country. So when you take the stone out of the ground, this is what it comes out like. It could be chalk, it could be limestone, it doesn't really matter of which level it is. Essentially, we're looking at a limestone based material which comes out of the ground in a rock format. We then take that and we burn it in a kiln. This is a photograph of a kiln at the bottom of Bluebell Hill. There were many different variations on the size and the shape, the height of them. It just depended on what materials they had available. So the limestone goes into a lime kiln and it's layered as you go up. And these kilns can be very deep. We could have a kiln maybe 15 feet tall in layers. So you have a fire pit at the bottom. You then put a layer of limestone, then coal, then limestone and coal, and you keep building it up. You set the thing on fire at the bottom, the lower part burns, and then it burns through the limestone into the coal, which then sets on fire, which then burns, and it goes up and up and up. And a typical lime burn could take 4 or 5 days in a decent kiln. So the whole thing starts really, it takes days and days to set a lime kiln up, and then many days for it to then burn through. And it gradually burns up, and it will then drop down. The burnt lime will then drop down into a powder, which is then sieved, and this is what it ends up with. So we end up with a pure lime powder, and we call this quick lime. So if you go to a builder's merchants now and you buy a bag of quick lime, this is what you're buying. This is a non-hydrated lime, so there's no water in it, and it's absolutely pure. This is immediately after the lime burn. But of course this isn't suitable immediately for putting into making a lime mortar unless you're going to be doing hot limes, which I'll get onto in a second. What you now need to do is take this product and slake it. And the slaking process is where you add water to the lime. And you'd always add water to the lime, never add the lime to the water, because it's an exothermic chemical reaction, which means it gives off heat and it has massive expansion. So you always add it in that way. So you get it in a bucket or whatever and you mix it around and it becomes highly volatile. And if I show you this little video, you'll see the slaking process in action. And if you just watch the surface of the lime, you'll see it bubbling, much like if you were boiling water in a saucepan at home. Now what's happening here is that the water is reacting with the quicklime and it's reverting itself back to a natural state. And this is the process that we call slaking. Okay, when the slaking process has completely finished, it will go solid, almost like a creamy, like a cream cheese sort of texture. And we call this a lime putty. So this is pure. Sometimes you'll see this referenced as being a fat lime, what's called a fat lime. There's many different ways of describing it, but essentially this is your purest lime format that you might use on a construction project or a construction site. So in this state, this is completely inert. It will now be cold. It will have cooled down. And this is the starting process for doing anything, whether you want a lime mortar, a lime render, a lime plaster for your ceiling or walls, it doesn't matter. They all start out in this way. And the only difference between a lime mortar that you're building your wall or your stone with, or a lime plaster, then maybe you want some really fine detail in maybe like a moulded ceiling, or you're striking a cornice. The only difference between any of these things is the sand that you put into it. So when you put sand into your mortar, at that point you are then changing the purpose and the use of your lime into whatever you want to do with it. But before that point, before you put the sand in, it can be used for anything. So I've brought some along to show you what it looks like. And I'm going to open this up. I'm putting my glove on because lime is caustic to skin. Now in this tub here, I've got, this is a non-hydraulic lime mortar. So it's very similar colour to the picture you see. And you see it's still soft. This is 2.5 years old. 2.5 years old. You couldn't do this with cement. If you mixed up a cement mortar in your barrow or whatever, it will go off. as long as this is one of the beauties of non-hydraulic limes, okay? As long as they are kept airtight, you can keep using it. I could keep this for 10 years. So this is a 2.5-year-old lime mortar that I've been using, and I've kept in this airtight container when I don't need it. And it will always remain soft like this. You can see it's completely fragile. Non-hydraulic limes carbonate. They require air to go off, unlike hydraulic limes, which I'll get onto in a second, which require water. And this is the primary difference. A non-hydraulic lime like that, if you had in some very large historic garden walls, perhaps around a country estate, which could be 3 feet thick, the lime in the middle of that wall, that could be 300 years old, it will still never harden, it will never go off, because it's completely isolated from the air. And hydraulic limes you could set underwater, because they require the water to harden. So this is one of the main beauties of using these products, is that they're highly variable. You can do anything you want with them. You can make them stronger, you can make them softer. And the Romans identified that by adding PFA, pulverized fuel ash, or pozzolanas, to your non-hydraulic lime, you can make it go hard. Because it is inherently a soft material, and when it's built into historic buildings, one of the beauties about old buildings that are historic, built with soft limes, is that they can bend. Modern buildings, if you get a structural movement or a sudden sort of ground movement or something, they will crack, because they're very, very strong and robust and essentially brittle. Whereas historic bricks and historic mortars are very soft. So this is why sometimes when you look at an old building, you look along the line of the bed joint and the brickwork's going like this. It's all distorted, because it's the ground has moved, or the building has had some movement, and they'll just bend because they're still soft. But sometimes you don't want them to be soft, you want them to go hard. So by adding a pulverized fuel ash or a pozzolana into the mortar, you can make it hydraulic and you can give it some hardness. And the Romans identified that, and that's all written in the book by Vitruvius. Now I'm going to move on to that in a little more detail. But first of all, I just want to talk about quickly 2 products which are often confused with limes, but they're not actually lime at all. And the first of these is Roman cement. Now, Roman cement is no longer available in this country, but when it was, there was one little tiny source just down here on the edge of the Thames estuary on the Isle of Sheppey. There was another source just at the tip of the Isle of Wight, and another source up here in Hull. And this is what it looks like when it comes out the ground. This is a septaria. This is what we call a septaria. It's a stone which comes out of this. What you're looking at there, this is the clay outcrop of London clay, but this one is on the Isle of Sheppey. And where the London clay comes up out the ground, it's got in it these rocks. And I brought one along to show you. In fact, actually, I've got a picture of it there. So when you see it laying on the beach or in the ground, you see this side of it. It's just basically a piece of stone. Whereas on the inside of it, you see it's actually like a gemstone, like some people collect these things, don't they, and have them on display. Now, back in the early 1800s, someone had the bright idea, whether it's by accident or what, I'm not entirely sure, of burning these stones in the same way that I've explained about burning a limestone or a chalk to make the powder, the quicklime, which becomes the lime mortar. And through this process, developed this product, which we now refer to as a Roman cement. But it's not lime, but it was used in a way that lime was also used. For example, for the renders on a lot of large London terraces, such as we see here, often you might see them referred to in the listing as having a Roman cement render, because it's incredibly hard and it's incredibly waterproof. This is its main characteristic. It's very, very strong and very, very waterproof. In fact, it's 100% waterproof. It will not allow water through it once it's set. And the other characteristic of it is it goes off incredibly quickly. Quickly being like 10 seconds, 10 to 15 seconds, certainly south of 1 minute from it being mixed up to being hard. So it was a team effort. So someone rendering this building would have had a team effort of the renderer, would have had a team of people behind him doing it. And it would stick to itself, stick to the building, but you can't ever stick to itself. So when these buildings have if it's a genuine Roman cement, for a start it doesn't need painting, but if it is painted and it then gets a section of it which is damaged, you've got to repair it with probably with a hydraulic lime. It was used to line the inside of the sewers. So when the sewers were put in, all these these bricks would have been set with a lime mortar, but with the water rushing through it, the lime would have washed out. So the pointing of these joints was always done with a Roman cement. Now, the only source of Roman cement left in the world is near Grenoble in France, and a company called Vicat make it, and I've brought some of that along to show you as well. So in this tub here, I'm just going to put this glove on just to show you, it looks identical to what you'd interpret as being a normal cement. So if I just show this to you here, and I just, it's just the same as a normal cement. The main thing about it is that you can mix it on a 1-to-1 basis. So 1 part that, 1 part sand, and it is just the most amazing product. And I think it's pretty much acknowledged that it built the Industrial Revolution during the 1800s. So the docks that the Victorians were building, the piers, all these amazing big structures which are all needing incredible strength and durability, was relying on this product. So there's only really one source about it. I mean, very few people would ever know how to use it in practice. You can slow that set down by using citric acid. So I said to you, it goes off really quickly. I mean, under a minute. You can retard it if you put some orange juice in it or citric acid. You can get up to about 10 minutes by putting a little bit of, you can delay that set. But essentially, you've really got to know what you're doing with it and why you're using it. And it's sort of a forgotten art now. There's a lot of conservationists would struggle to understand how they could use it. But it's an amazing product, and you might end up needing to use it one day. So it is available, but you've got to import it in from France. The other product which you'll come across from time to time, which is not a lime either, but often confused as being a lime, is Code Stone. So this very famous line, this is on the south side of the River Thames, opposite the Houses of Parliament. So you go across Westminster Bridge, and this line sits very proudly by the side of the road. It's not a carving, it's not stone, it's not lime either, it's Code Stone. And Eleanor Code, which is where the name comes from, she invented this product which took her name. And she lived in this property in Lyme Regis called Belmont, which I've been fortunate enough to do the survey of. And all this detailing around the building, this is not stone carvings or even a lime mould. This is Code Stone. Now, she died taking the recipe. No one apart from her knew how to make this stuff, and she died with the recipe. And so on her death, her company gradually had some supplies of the stuff, and once they run out of supplies, the company ended up having to close because no one could remake it. And it was only as recently as about 10 years ago that a chap doing his PhD decided he was going to try, through repetitions of experimentation, guesswork largely, he eventually worked out what the recipe was. And I can't remember the exact proportions of, it clearly has some limestone in it because it's from Lyme Regis and there's a lot of that in there, but there's lots of other things. The key thing is it's fired 4 4 times at about 1,500 degrees Celsius. It's almost like a ceramic. So it's much higher than the firing of even making a Portland cement or making a hydraulic lime, which we'll get onto at the moment, which will be about 800 to 900 Celsius. So it's incredibly hard wearing, but it's not a lime mortar. So it's really important that just make that distinction. So Roman cement is neither Roman nor a cement, but it's certainly not lime, and Codestone is not the same product as a lime either. So the critical thing that comes up over and over again is when we're talking about lime mortars, hydraulic or non-hydraulic, and it is really important that I sort of explain the difference of this, because there isn't actually such a thing as a lime mortar. And very often in terminology of when people talk about a cement mortar versus a lime mortar, it's quite important to understand that actually generalizing and saying a lime mortar is like saying you're going to go and buy a red car. Well, do you buy, a Ferrari or a Ford Mondeo? They're both red, but they're completely different. And in the same way, for purposes of conservation and using these products, a hydraulic lime is very different to a non-hydraulic lime mortar. So we'll go back to my little map. So we're concentrating the geology around this south and southeast part of the country, and the stone which comes out of the ground and the lime that comes out of the chalk is very, very pure in this country. So it has very little in the way of impurities, and it is non-hydraulic. So spot the difference. Hydraulic lime, when you buy a hydraulic lime, it'll either the two main suppliers that people have access to in this country are Synastia and Singleton Birch. And Singleton Birch import theirs from France. These products are coming in from France. They're not native to this country. So it comes in a bag form, much like you would buy your cement, your Portland cement or whatever variation on the theme. Whereas a non-hydraulic lime comes in tubs. You can buy it in tubs, pre-mixed, much like I've just shown you. And one of the advantages about using the product is that often when architects and surveyors get worried about the specification of their lime, they don't know what mix to use, what proportions, what types of sand. The beauty is you don't have to worry. You can buy it in and it can be pre-made. So there's a number of suppliers. This particular one is Welsh from Timor. They're one of the largest suppliers of non-hydraulic limes. And as you can see here, they colour it as well. So you could, if you're trying to do a repair to a stone wall or a brick wall or whatever, you can say, well, my mortar's kind of like that colour, and they will blend it, and the colour always comes out of the sand, and they will be able to adjust the mix to suit your specific needs. So you could take a photograph or take a chunk of the mortar and send it to them, and then it can be delivered to you in 25 kilo tubs already pre-mixed, so you don't actually have to mix it on site. So this now opens up a whole new world of avoiding on-site practical mistakes being made by people who are not familiar with using lime mortars, but perhaps they've got the right skills in terms of pointing or brickwork or stonework. And it's now the fact that we can buy it in pre-mix now means that problem has been eliminated. If you're still using, or people want to use, a hydraulic lime, it's really important that they use it for the right reason, and I'm going to explain about this in a second. But it does, of course, bring with it the complication of mistakes being made on site through its use, or more specifically, the misuse of the product. So let's talk about hydraulic limes first of all. The key difference between a lime mortar, well, a lime being a hydraulic or a non-hydraulic lime, is that hydraulic limes have impurities in them. They have clays, silicates and aluminates, and these are the same impurities that go into a Portland cement, and it's the impurities which give the product its strength. But these are the three variations that you'll tend to buy a product, and they're hydraulic lime, and they're always prefixed by NHL, natural hydraulic lime, and then you'll have this number 2, 3.5 or 5. These numbers are assigned in a laboratory, and it refers to its 28-day curing strength. So this means 2 newtons per millimetre squared after a 28-day set. So clearly 2 is a softer mortar than a 5. But in practice, it's very difficult to control that accurately. So your NHL2 in reality might set to an NHL 5, or your NHL 5 might set to an NHL 10. It might be really, really hard. So we used to use these words, feebly, moderately and eminently hydraulic. But now, because the European rules being what they are, everything has to be standardized. So you will always see NHLs prefixed in this way. And in use, you're probably going to be using something like an NHL 5, where you want a very strong waterproofing surface. So perhaps where you've got a roof which is abutting a chimney, and often you'll have the choice then, well, what do you do where you've got tiles hitting a brick surface? Most people these days will put a lead flash in, but on older buildings you might see a clay tile fillet or a mortar fillet up the edge. Well, in those situations where you want a completely waterproof surface, you're probably going to be going for something like an NHL 5 if you were to use a hydraulic lime. On the other hand, if you were doing some pointing on let's say a brick wall or a stone wall or something, you might want something a little softer, so you might go for something like an NHL2. And everything else in between, if you're doing internal work, you might choose something in the middle. But the decision as to what you use is often guesswork by the architect or the surveyor, because often there's a considerable misunderstanding as to what these products are. And it's really important that you understand that in giving the mortar strength, so by going up the rank from a 2 to a 5, in having that extra strength in the mortar, what you're taking away from it is the breathability. And a critical factor that is so important to all historic buildings is that we want them to be breathable. So moisture that gets into the wall or through the floor or through the wall through rising damp or penetrating damp can then get out again through natural heating and ventilation, and we call that process breathability. But when you have an NHL, a natural hydraulic lime on it, in having that extra strength, and there are clearly occasions when you'll want strength in your mix, you're taking away the breathability. So it's really clear that the decision to use an NHL mortar has to be thought about what the consequences of that are going to be. So there's a direct trade-off between strength and breathability. So the difference though with non-hydraulic, the difference between that and a non-hydraulic lime is that there is no trade-off. Non-hydraulic limes are completely breathable. So it can get saturated, you can chuck a bucket of water at it, it can get wet, and then it will dry again. The water will be able to escape and it will release itself through natural evaporation. So a non-hydraulic lime will carbonate in air, and I explained that tub of lime there is 2.5 years old, and the reason why it's never set is because it's kept in this tub with the lid on. Whereas when you take it out and put it onto a brick wall or whatever you're using, then it's exposed to the air and then it will start to harden. So it's that air sort of exchange that creates that set. Now that set is influenced by air temperature, and particularly by when level temperatures are very cold or very hot. The optimum outdoor air temperature for using this sort of product might be, sort of between sort of 12 up to, maybe 20 degrees Celsius. So your typical sort of spring into summer day. It's really tricky and really inadvisable to be using these products outdoors like right now, this time of year. You might have a nice sunny day during the day, and when you're advising your contractors on site or your client, it can be sometimes tricky to explain to your client, well, it's a beautiful sunny day, but no, they can't work today. And the reason is because it's not the daytime temperature, it's the overnight air temperature which is the critical factor. And when the overnight air temperature drops certainly below 10, definitely below 5 degrees Celsius, you're at serious risk of damaging the lime mortar. The first 90 days of that lime mortar set are critical to its entire lifespan. So trying to save a couple of weeks by allowing your contractor to work in a unprotected on a scaffold maybe which is unsheeted and unheated, you're potentially risking the entire lifespan of the work what that contractor is doing. So it's important that you have an awareness that the window of opportunity for using these products outdoors might be between, say, April, late March into April, Easterish is normally the rule of thumb, through to sort of late September, early October at the latest. Outside, so those are the sort of good periods of the year. Outside of those years, those months, you must be aware that the mortar itself will be at risk, and therefore if the contractor is working in an environment where it's particularly hot or particularly cold, that mortar could be permanently damaged. So it's not to say that you can't work outdoors, it's just that you've got to take precautions in those winter periods. So by using a fully sheeted scaffold, maybe even having heating on the outside of the building to heat the scaffold, to keep the air temperature up overnight, putting carpet over your wall or something overnight, whatever you might need to do. But frost is critical to this problem, and if your new mortar gets frost damage, you may as well not have bothered to do it at all. So right now at this time of year, no one should be really working outdoors in an unprotected environment. So another key thing which is often misunderstood is that you can reuse it. Sometimes you go into an old building, you've got a lath and plaster ceiling and it's all cracked, maybe it's even loose, so you can put your hand on it and you can move it. You can reuse these. It's almost like the ultimate in recycling. Drop the ceiling, or if it falls down anyway and it's all over someone's floor, as long as it hasn't got wallpaper on it, it can have multiple layers of paint, and also as long as it hasn't got gypsum plaster on it. If it's just your pure lime plaster, break it up, stick it back in your bell mixer on, say, a 50-50 mix with new lime mortar, and it will, once it's wet, it will hydrate itself back to its natural state, put it straight back up on the wall, on your wall or your ceiling. It's definitely recyclable, and you can. There's no need to stick it in a bag and skip it away, provided it hasn't been contaminated with gypsum and wallpaper or ceiling paper or whatever. So the other important factor is that the breathability, unlike the natural hydraulic limes, the NHLs, the breathability is not affected by the mix. So if you're using a very weak mix or a very strong mix, and I mean that depending on how much sand you've put in it, it doesn't matter. You'll only have that judgment based on what you want to do with the mortar, but the breathability is not affected at all. So it is just the most amazing product. So the variation on this slaking, which I explained to you, which is usually done in advance, and you store your lime putty, and the longer you store your lime putty, the better. That lime putty, before that was made into that mortar, was 6 months old. So that mortar is 2.5 years old. The putty that it came from was 6 months old. So actually it's now 3 years old. The longer you leave it, the better. And both Vitruvius and Palladio, who wrote his book, the 4 books of architecture, both Palladio and Vitruvius have explained that in their book. So they knew this, in that case 2,000 years ago, and in this book, which came from the mid 1500s, they were explaining about they had the awareness that leaving your lime putty, just chemically, it's like a good wine, it just gets better and better with age. But there is this other technique, which I'm going to just explain to you about now, which is the complete opposite. It's where you, much like on a modern building site, you've got your bell mixer, put your cement in, put your sand in, chuck a bucket of water in, mix it up into a mortar straight on the wall, and it's job done all in one day. The variation on that using lime is what we call a hot lime. So around the perimeter here, you've got your sand, you've got your mortar in the middle, and then not your mortar, your lime, your quick lime, effectively unslaked lime there, this white powder, and then you add your water to it, and then immediately you add your water to it, you mix it in, and again, it's really, if you've got 2 or 3 people doing that with the shovel, the better it is, because that exothermic reaction, which I showed you on that little video, it really starts kicking in instantly. So you've got to keep turning it over with the sand, and eventually you are burying the lime into the sand, and that heat does the slaking process, and it will start to steam and bubble, and it is quite an amazing procedure when you actually see it for real. And then once that slaking process has taken place, you can use that lime mortar, because it's then a lime mortar, but we call it a hot lime. You can use it straight away in the same way that you would be using your cement mortar straight away. You can use this straight away, so you allow the slaking process to go off, and then you can use it. And it's always easy to identify on a stone or a brick wall when it's had a hot lime process, as opposed to the stored lime putty. Now, because if you look at ignore all the cobwebs, which are just from a spider, can you see in this mortar here, we've got these little white chunks. When you see this in the mortar, this shows that this is a hot lime, and because it will never be 100% perfect, you always get these unslaked little chunks in the mortar, and that's what that is. So we know that by looking at this photograph of these brick joints, that this brick wall was made with this is from a hot lime mix, and that's a slightly out of focus image, but you can see these chunks on this flint wall here. We've got this flint, which is also done with a hot lime. Now, this is quite important to have this awareness in conservation, because if you're doing some repairs to a historic building and you see this type of mortar on your wall, and you may be wanting to either extend the wall, or maybe part of it needs rebuilding, it's quite likely that the conservation officer, or Historic England, if it's a grade 1 or 2 star building, will require the choice of mortar on that repair to be a hot lime. And so as soon as someone sees that, they'll be saying, yeah, okay, you can have your lime mortar, but it's got to be a hot lime. So the contractor who's mixing it must know what he's doing. You can't buy this in a container or whatever. You've got to be familiar and know how to mix it. And it gives the wall a nice pleasant appearance. So the next advancement that I want to talk about is how Portland cements, ordinary Portland cements, come into the equation, because there's right now, as we're into now the 21st century and the 20th century which came behind us, everybody's using Portland cements for everything, from floor slabs to brickwork to stonework to massive concrete constructions. So if you have a look at this very interesting image, I want to explain to you just what the difference is. So this wall here, about half an hour before I took this photograph, it had rained. So the wall was subject to the same amount of rainfall, but you can quite clearly see the different colour band. So on your right here, this wall here, this is a 17th century brickwork which has never been repointed. It's not in brilliant condition, but it's not in bad condition either. Here, this is a 1965 extension. It is in Flemish bond, but you can see the smoothness of the bricks. In fact, the bricks are slightly different size, as modern bricks are. But this has got cement on it. This has got lime on it. And you can see that the wall was saturated through the heavy rainfall, but already after a relatively short period of time, this has held on to the moisture, and this side hasn't. This has already started to release it as the wind and the sunshine has come out. And you see this over and over and over again. Any situation where you get cement on historic bricks where they want to release, because historic bricks are largely porous, unlike modern manufactured bricks, which are much stronger, and clearly engineering bricks are completely waterproof. We see this over and over again. Now, the implication of this, where you've got the cement, is that it's fine if you're building your cement using modern bricks or modern concrete blockwork, because they're all designed for the same purpose in mind of strength. The problem comes when you apply a cement to a historic wall or another surface where it's been previously intended to have lime, or historically it would have had lime. And this is what's going to happen. We get frost damage. So on this example here, we've got a historic brick which is soft. This dark colour surface, we can tell that this came from a timber-fired clamp. So the outside of the brick is the hard bit. If you pick one of these up and knock it with your knuckle, it's going to be really hard, and you'll understand that bricks are really hard. But actually, they're very soft and brittle. You could probably snap it quite easily. So that outer part of the brick, which is the hard bit, once it's eroded away, you get the inner clay exposed. Now, this damage that we see here is not caused just because this is an old brick. The damage is caused by the mortar. The cement has held the moisture into the brick. Here, this actually, I wanted to show you this. I'm doing some research on Venice, and I went to Venice a couple of weeks ago and I took a whole series of pictures, and I wanted to show you this because you'll never in your working career ever come across this type of cement because you can't buy it in the UK. This is a Portland cement, but this is what they in Venice they call it a pozzolanic Portland cement. So I explained earlier that the Romans had identified that putting pozzolanas and PFA into their non-hydraulic limes makes it go strong. Lafarge Tarmac, who are a major manufacturer of cement, have been developing this cement for use in the Mediterranean countries. So this is a Portland cement, but with pozzolanics in it to make it really, really hard. And it's specifically, I'd never seen this before, and it specifically says on the technical spec of this cement, when I looked at it, it's not suitable for brick walls. And here you can see a brick wall which has suffered huge amount of frost damage to the point where actually the clay has got completely desiccated, yet the mortar is completely okay. It's really super duper hard, but you'll never come across that. But you will see the example of cement over and over and over again on historic buildings. Here we see a pair of stone gate pillars which have been previously rendered in a cement to make it up, and look at the erosion that's occurred on the stonework. Here a flint wall completely messed up, as you can see, by the overuse of the cement. On a cob building, which you won't get in this part of the country, but going further west down into Dorset, across the southern part of the England, Devon, you're going to find a lot of these cob buildings. This would have had a lime render on it. The lime's come off, someone has rendered it with cement, and this fissure right down the cob building is caused by the cement render on it. Okay, so it's really clear. Here's a bad one. This is a cob building which collapsed. This collapsed because of the cob had dried out so much because of the cement render. Down it came. And here's another one. So the cement is really damaging on these buildings. So when doing conservation repairs, it's very important that you have an awareness of what the consequences are of using the cement, and the importance, therefore, of why you shouldn't necessarily use it in those situations. Good product, but use it in the right places. Here we've got a chalk building. Chalk is a very common, again, not necessarily in the south of England, but in some parts of the country, a very common building material, but again, should be pointed with lime. It would have been bed in lime, and it should be pointed in lime. And here you can see where it's been repointed, and this damage on the surface of the stone here and these little cracks, this is caused by the use of the cement. And here's a close-up. Can you see the erosion, how the wall is now gone quite concave? And this is again a cause of the cement. But perhaps more commonly in this part of the world, you're going to be seeing chimneys and walls repointed using a cement. So a cement is very similar chemically. A Portland cement is very similar to an NHL in that you're still using the raw ingredients, but the way that it's manufactured and the outcome of it is entirely focused on trying to develop a product which is super strong for use in construction. And there are many, many examples why that's a good thing. Where conservation is concerned, it doesn't work. It doesn't work in these situations. And as you can see here, these bricks have been irreparably damaged. Look at this here. Okay, and this is caused by the cement, and here's another example. Same with cement flaunchings on the top, and here's another chimney. Is a good close-up. You can see how so in there we've got the lime, and look, even just a few millimeters of a repointed brick wall will be sufficient to cause this damage. There's a brick which has gone concave. Once that outer few millimeters of the brick comes off through the frost damage, it's a one-way street. It's irreversible. It will get worse and worse because that inner clay is so soft you can scratch it out with your fingers. Similarly, on the inside of a house, when you get traditionally a lime plaster, and it allows that moisture to evaporate. When you put gypsum plasters on to these old buildings, you're going to get an increasing amount of dampness in the building. So often people interpret that as being rising damp, and you see the little blisters on the paintwork here. These are not caused just because the house was built with no damp proofing, which of course all old buildings, certainly prior to 1877, which is when DPCs were first installed, none of them had any damp proofing. But these problems are caused because later alterations to the building, particularly using gypsum plasters, have elevated a problem which was manageable, allowing the moisture to ventilate. Suddenly the building is sucking all that moisture in and it can't allow it to evaporate. And here, good example, look, this is your original brickwork with your lime mortar, which has then had a gypsum skim over it. Someone's thought, oh, we can tidy that up. You know, the plasterer can float his gypsum over it. And gypsum, as you know, is pink, and it will always go wrong when you get this combination. So trying to use your cements and your gypsums on any old building, doesn't have to be listed, any old building is always a one-way street to a disaster waiting to happen. So when advising your clients as to what materials you're going to be using in the repair, bear in mind that the day it's finished it might look great, but come back in 5 or 10 years time and you might be having a different situation. So just to bring it all to a conclusion then, working with lime outdoors is really something to be done during the spring and summer. It's not something to be done this time of year in the winter time, certainly between, let's say, middle October, end of October at the very latest, through to about Easter. And it's absolutely fine to work outdoors during those periods, but only if you take adequate precautions to protect your lime against the overnight air temperatures. It doesn't matter if it's raining, it can get wet, that's absolutely fine. It's the temperature which is the critical factor. And similarly, if you are working during the summer months, what you want to do is avoid the moisture in your new lime mortars or renders evaporating too quickly. So you'll need to be using sort of damp Hessian sheets or whatever, or have a fully sheeted scaffold simply to protect it against the sunshine. So these two extremes of hot and cold are what you need to try and avoid. So we have this window of opportunity. So it's absolutely fine to work outside as long as you're aware of that, but it is critically important because that first 90 days, just to summarize what I said earlier, that first 90 days is where it's really, really important. So just to wrap it all up then, from a practical conservation point of view, where you're most likely to be using your limes are on lime mortars for repointing or for repairs, maybe lime plasters internally if you've got to put new ceilings up or new walls. In these situations, you're going to be needing a non-hydraulic lime. It's absolutely fine to use a hydraulic lime if you understand why you're using an NHL and what the implications of that are. Don't just randomly specify an NHL without understanding that you might be delivering to the building a problem. So where I was just showing you the pictures of the chimneys with the cement on it with the frost damage, you can equally cause that problem if you're using an NHL which is too stiff. So if you were repointing with, you know, an NHL5 in a situation where it didn't need it, for example, perhaps an NHL2 might work. But if you're going down there, why use an NHL at all? You can buy the stuff in, you know, a 25 kilo tub is about £8.50, £9. Okay, for 25 kilos pre-mixed. I mean, it's not even like a cost factor in your decision making. It's, you know, so I would strongly suggest that you understand what the difference is. And also the beauty now of these things is you can buy them in pre-mixed. So the problems of years gone by about batching, not knowing what specification to use, you know, these have gone away. You just tell the supplier, show them a photograph, tell the supplier what you're doing, and it will be delivered to your site ready to go. Take the lid off, chop it in, put it in the Bell mixer. With a 25 kilo tub like that needs about maybe half a pint of water, and it'll be perfect. Mix it for about 20 minutes, straight off into your use. So so it's really easy. And finally, hot limes are just an amazing product and an amazing way to use lime with a really effective appearance on the wall once it's been done, but only if you know what you're doing with it, because you know you can see from the photograph you've got to be very quick, you've got to mix it, you've got to know what you're doing, because if you get that batching wrong, you get the slaking wrong, then you're going to end up with a lime mortar which is not properly mixed, and it will just go wrong thereafter. So in a nutshell, you have two choices, a hydraulic lime or a non-hydraulic lime, and in conservation repairs you're more likely to be specifying a non-hydraulic lime for your repairs. If you are building something from new, like a new wall, or you've got to do you know, some repairs, then sure, your NHL might well be the correct option for you, because you might want that extra strength, but just bear that in mind.